Okay, so this is what our lab looks like. So we can throw our data in here. We've got our base units over here. We've got the equation for density over here, and kind of shows what units go with it. So, for example, the mass of the graduated cylinder they had was around 103.4 grams. The volume of 1/4 of a cup of vinegar came out to be about 60 milliliters for me. The mass of 1/4 cup vinegar and the graduated cylinder together came out to be about, it's like 163.7. All right. So if we take that 163.7 and subtract out the graduated cylinder, the 103.4, that comes out to be, well, that goes away. So 60.3 grams. All right. And the density is taking the mass divided by the volume. So in our case, with this example, the mass was 60.3 grams divided by our volume, which was 60 milliliters. Oop. There we go. Okay. So if you run that through a calculator, it comes out to be about 1.01 grams per milliliter. So 1.01 grams per milliliter. Okay. Now the density is supposed to be 1.02 grams per milliliter. So you might think about what could cause the difference. You know, it was close, but why isn't it exactly 1.02? Okay, what happens in the lab that can affect our results and make it a little bit different? Okay, and down here we have some more places where we can put our data. So like the mass of our 1 tablespoon of baking soda, write that in there, 15.7 grams. The reaction took about 1 minute and 3.66 seconds. Okay, or since 1 minute is 60 seconds, you could say 63.66 seconds, something like that. The mass of the wooden block was about 7.3 grams, and each side of the wooden block was about 2.5 centimeters long. So the length of the side of the wooden block is 2.5 centimeters. The area would be 2.5 times 2.5, so two of the sides multiplied together. Okay, and that comes out to be about 6.25 square centimeters, okay, or centimeters squared, which is how we get that area. Centimeters times centimeters. All right, the volume of the wooden block would be 2.5 centimeters times 2.5 centimeters times 2.5 centimeters, so like the length times the width times the height, okay, or 2.5 cubed. It's the same mathematical thing, which is why we have cubic centimeters or centimeters cubed over here. When you multiply all these three together, this is 15.625 cubic centimeters. Okay. Now our density is going to be our mass divided by the volume of the block. So if we take 7.3 divided by 15.625, what we get is a density of about 0.4672. Okay. Now you can round this a little shorter if you'd like. So you can round it up to maybe like 0.47. Usually 2 or 3 decimal places is good. So I'm going to do that. I'm going to round it up to 0.47 grams per cubic centimeter, or grams per centimeter cubed.